Alrighty, we are live. Hello, everyone. Thank you so much for joining in this particular webinar. Super excited to have you all here. If you're new here, my name is Kunal. I am working as a DevOps engineer at Randoli, and I'm joined by Rajat. Rajat, would you want to tell everyone a bit more about yourself and what you do?
Hi, I'm Rajat. I'm the founder and CTO for Randoli. Really excited to do this hotel webinar with Kunal.
Amazing. Yeah. So I hope some people would be familiar with both of us because we have been doing a bunch of webinars recently. If you've been following the channel for a while, we have been talking about cost management. We have done two webinars on that. If you are interested to know more about Kubernetes cost management, we have covered what are the challenges we that exist and what are the basic concepts that you may need to know. You can check out the description later after this particular video to know more about that. But this particular series is all about OpenTelemetry, right? And because OpenTelemetry is a topic that has been discussed for quite some time now, and it is one of the most hot topics in the recent KubeCon and the whole Cloud Native ecosystem. So we thought, I think it would be great to have a series where we help people understand what are the different use cases of OpenTelemetry and how you can actually start implementing OpenTelemetry into your existing infrastructure to get the benefits of vendor lock-in and so on and so forth. So this is something that we are going to cover today. Pretty excited for this one. So maybe I share my screen and we can get started with that. Okay, add to stage, share my screen. Alrighty, so for the folks who are joining this particular webinar, I love to know from where you're joining in. I already see I think 5 to 6 people are live with us, which is pretty good. A good number. I think more and more people will join in, but would love to know from where you're joining so you can say hi in the chat. All right. But yeah, if we quickly get started with the things that we are going to cover today. So what we are going to do is this is the first webinar for OpenTelemetry, right? We are going to go through all the code and the basic concepts that anyone needs to understand in order to implement OpenTelemetry, understand why it is necessary, why it came into being, right? And how does it actually solve the existing challenges in observability, right? So this is a sort of a basic overview of what we are going to cover. But just to quickly start with, right, this is a glimpse of OpenTelemetry adoption and the massive increase that we have been seeing in the cloud native ecosystem for a while now. So these both statistics are from a recent CNCF report, and you can see the project started in 2019. It joined the CNCF ecosystem in 2019, and throughout these years, we have seen numerous number of companies, numerous number of contributors from across the globe contributing to this project. And you can see this particular graph. These are basically the contributions done by the companies, right? So you can see the number of contributions that have been increased throughout these years. And Rajat, I think you also went to KubeCon this time. So what are the kind of discussions that you saw people were having related to OpenTelemetry adoption? Did you saw an increase in the discussion, or what was happening there?
Yeah, OpenTelemetry was one of the more popular, I guess, topics. There was a lot of buzz about it, people asking about OpenTelemetry, people trying to learn more about OpenTelemetry. And this time at KubeCon, generally you find they have the CNCF project booth, and that's where all the CNCF projects are. But OpenTelemetry had its own booth, in a really large booth. So that tells you the sort of like the interest and the adoption. What's really interesting about OpenTelemetry is that it has a very vibrant ecosystem, like you mentioned, lots of contributors from not just not just from observability vendors, but also from other ecosystem contributors as well, right? Like AWS, etc. So it's really good to see the kind of like the interest and more importantly the contributions from sort of across the spectrum. And you have interest from different industry verticals as well, like people from telecom talking about it, people from automotive industry talking about it. So it's there's I'm looking at it as a very vibrant, healthy community that's continuing to grow. So I am not surprised to see the adoption and being probably the most popular CNCF project, I guess, at this point. Yeah.
Yeah, totally agree with that. And that's why I feel that's why we felt that this particular topic is really needed, this kind of a live series where we talk about different aspects of open telemetry. So for the first one, we are going to keep things simple for everyone who's listening for the first time. We are going to start with the why, like what are the existing challenges in observability. Then we are going to talk about what and how, like what is open telemetry, how it solved those challenges that we are talking about. And then at the end of the day, we are going to show you a great demo of a mon application, so you'll have the entire picture, sort of like a hands-on demo, right? So Rajat, I think you can start us off by discussing the why part, right? Why does open telemetry exist, and what are the current observability challenges due to which open telemetry later was born?
Yeah, I think that's a great way to start. Why this kind of explains why open telemetry came into place, and then like why was it created in the first place, and then why is it so popular? As the complexity of the applications started to grow, like we moved from monoliths to microservices. So did the observability challenges that grew alongside it. If you look at the observability market, that has been growing at a steady pace, and various vendors came into the picture to solve these observability challenges. But everybody had a slightly different approach. Yeah, to get more deeper visibility, people had to instrument their code. So there was proprietary SDKs, different libraries, different tools. So what that also meant was, you're locked into a particular vendor because you are using their SDKs. You were using the data formats were proprietary, etc. So there's no interoperability. Kind of like very locked into whatever that vendor provided. And then alongside that, there are other operational challenges that came about as well, right? Like the setups were complicated. I mean, there was Kubernetes, there was people are moving to the cloud, microservices, all kinds of um, things started to happen as well. And in that particular kind of environment, as things the complexity grew, how do you optimize all of these things? So there was several other attempts as well. There was open tracing. There was a before open telemetry came into being. So people were trying to figure out this challenge of how do we have a sort of like a vendor neutral open standard when it comes to telemetry, and that's how open telemetry started. These challenges were the sort of like the reasons behind the existence of open telemetry.
I completely agree, and I think this is because open telemetry, we'll definitely understand how it solves this. And I think because these are so fundamental challenges, that's why I believe that the adoption of open telemetry has thrived in these recent years, because it solves these fundamental challenges for a lot of organizations, right?
Yes, I mean it's not a I mean it's not a perfect standard like any other standard out there, but it's certainly a step in the right direction. And it's by the number of like the number of vendors that are participating, the number of ecosystem partners that are participating, and then the wide adoption is proving that people are willing to work with it and continuing to improve and evolve it. And it's also an extensible sort of ecosystem where people are looking at using open telemetry in some other interesting use cases as well. It's today's probably not the day to talk about those things, but it's fair to say that it's a growing, vibrant ecosystem, and people should be paying attention to it. Yeah.
Amazing. Yeah. Thank you so much for sharing that, Rajat. So let's talk about the solution now, right? We have been mentioning about open telemetry and why it exists now. So what exactly is OpenTelemetry? It is an open source observability framework, and it's important to understand that it's a framework. It's not an observability tool or an observability UI, because I feel a lot of people confuse with that. It's a framework which gives us the rules, which gives us the specification on how the telemetry data is collected and exported, right? So it standardizes how the telemetry data, logs, metrics, and traces, which we'll talk about later as well, is first collected and then exported to different backends, right? OpenTelemetry, the framework, it works with any backend which supports OpenTelemetry, right? Any OTel supported backend, for example, Jaeger, Prometheus, or if you are using, let's say, a custom solution, for example, Randoli or any other solution out there, if that supports, if it is OpenTelemetry native, you'll be able to view all of your telemetry data in that particular solution, right? It supports multiple programming languages and multiple environments. You can run this on your Kubernetes infrastructure. We'll talk more about that as well. And it supports multiple programming languages so that you can instrument your code in any language of your choice based on the application that you're using, and it should be good to go, right? And lastly, because we have been talking about the adoption, it's a CNCF incubating project and has quickly become the de facto or standard of observability, just like Kubernetes became the de facto at one point for containerized applications. I think OpenTelemetry is heading that way for observability, right? So all in all, this is what OpenTelemetry is. And just to summarize that a bit, the main goal that OpenTelemetry is trying to solve is how you can enable easy instrumentation of your application or system, and regardless of the observability vendor that you're using, regardless of the programming language that you have used in your application, the infrastructure that you're using, or the runtime environment which you're using, right? So this is, I hope this gives you a good gist of what OpenTelemetry is all about and the problem that it's trying to solve. So if we go into the core concepts, right, that you need to know in order to understand how OpenTelemetry is working underneath. The first concept is basically the signals, and signals are essentially the telemetry data which your applications, which you are exporting via your applications, and then you are viewing using the observability backends. Currently, OpenTelemetry supports traces, metrics, and logs. That means you can easily instrument traces, metrics, and logs from your application. And through the OpenTelemetry collector, which we'll talk about a little bit later as well, you can view these into your custom backend or any observability backend that you wish. Uh, the signals which are under development right now are the events and the profiles. So these are under development, and the community is working on including these signals and trying to get these running in OpenTelemetry too. But this is something that this is the first concept that you need to understand in order to see how OpenTelemetry is working in the backend. But Rajat, do you want to take from here and tell everyone about what do we mean by distributed tracing? Because if you search on Google about OpenTelemetry, distributed tracing is something that will come up, right? So I think these two are very much related. So we
Yeah.
can take this topic ahead.
Yeah, for sure. I think today we are going to focus a little bit more on the tracing side. I think most people understand metrics, most people understand logs. Distributed tracing, it started to get more popular alongside microservices. You took one monolith and you broke it into multiple microservices. And then along with that came the challenge, how are I going to debug this, right? Because these microservices are, completely different runtimes and sometimes written in different languages as well. But how do you, trace a particular transaction across the microservices, right? I mean, what I have here is a fictitious order processing system. Maybe from the front end, someone is trying to create an order. They click purchase on the or buy on the shopping cart application. It hits an order endpoint. That could be modeled as its own microservice. But now, in order to fulfill that order, you may have to look up certain information for those items. So it goes talks to a product catalog service. It needs to arrange for shipping. So you need to talk to like a shipping service. Maybe need to coordinate with an inventory service. Maybe need to coordinate with a payment gateway, which I haven't even put anything over here. So you need to to fulfill that order, where you get perhaps a single endpoint to actually, to create that order. Multiple uh, operations has to happen in the backend, and any one of these operations can fail. Any one of these operations can slow down. Any one of these operations can have sort of, subtle issues. And when you're debugging performance issues, or you're debugging an error, now you need to trace that uh, first call, the order that got placed in, across all of these microservices. And that's challenging, because if you don't have a way to correlate your logs, your metrics and traces, then it's going to be very difficult to, from a debugging perspective, right? You're going to look at hours and hours of logs, and look at different metrics, try to correlate them. That's going to be very difficult. So distributed tracing was a way to um, trace a particular context across how, when propagating through these microservices, and trying to figure out how much each of these stages took to complete, right? Like, what's the processing time look like? What are some of the additional data that we can look at from each of these steps? Was there any other error? Was there any errors in this process? Was there any other complexities that are alongside that? How do we capture all of that, right? So that requires some sort of coordination, and some sort of what I would call context propagation. And that's what the distributed tracing is trying to solve, right? And with OpenTelemetry, we talked about that being a signal. This context propagation is a key sort of concept. What it allows is to trace exactly what I talked about, right? A transaction going through order service to the product catalog service, going to shipping service, going to the inventory service, which is actually completely decoupled as well. The other ones in that diagram was synchronous, but going to the inventory service was a Kafka message. So how do you really debug all of this together, right? And that's what this distributed tracing is about. So in the context propagation case, what's happening here is uh, you here you can see a simplified diagram where, from front end it goes to another service, and from there onwards to the checkout service. So they're trying to capture all of those steps, and and preserve that context for that particular transaction, right? And these are modeled as, if you go to the next slide, I think it's easier to explain. These are modeled as spans. So each of those steps within a particular process or a service, it could be a Lambda function for all we know, but all of those steps are, you can think of it as a series of operations that are modeled as spans, right? And and then now when you move from one service to another, so in this particular case, let's say from the order service to the shipping service, it not only you have to capture those spans, but you have to propagate that context for that particular transaction to the next service in the call chain, which is in this case, the shipping service. Or this one is an HTTP request, but let's say in the case of talking to the inventory service, in this case it's a Kafka message. So if you figure out a way to propagate this context across different communication mediums in a standard way, then you can continue to add, using that context, you can continue to record those different stages, right, within a service, so that when it comes to debugging, it's easier to see what are the different steps it took to fulfill that order request. What are some of the attributes that were attached to these, so you can get more insight into the process, and then tie them all together using that context, so you can see an entire call chain end to end, regardless of how that process was executed or orchestrated, right? Could be HTTP, could be Kafka, could be some sort of a JMS provider. You should be able to tie in all together. So that's that whole context propagation, I guess, concept of context propagation, where you are able to capture certain information that allows you to tie in uh, various different execution flows that are all related to a particular business context, like a transaction. It could be like an order. It could be some sort of a financial transaction. It could be like a payment action. It could be how would I say, like a someone executing like a mortgage application, etc. It helps you to track a process as it moves through the system. Yeah. Uh, let's move on to the next one. I believe we have. Yeah.
Yeah, I think for folks, because we are going to show this in the demo as well today, so you, I think, have a better idea of the concept of context propagation. But just to iterate back on this particular diagram, right? So here you can see that when order service was hit, you can see the entire flow of the request, and the why behind this is because OpenTelemetry supports context propagation. So each and every service which is getting hit, even if you hit the product catalog service, you'll be able to see all the related service that were hit which are connected to the product catalog service. Why? Because each and every request from each different services has that context with that, and it travels with the request, right? So so at the end of the day, you'll be able to track the request from end to end, right? And you'll have a better picture when we'll show you all the demo that we have today at the end of the day, so you'll have a better idea of how this thing looks in real life. Alrighty, cool. So these are the two fundamental concepts that you need to know in order to like understand how OpenTelemetry is working underneath it. One is signals that we covered, another is context propagation. Let's move on to the how part, right? So we covered the why, we covered the what. Now let's cover how does OpenTelemetry work and how does it do the things that it does, right? So these are the main components, the key components and the building blocks on which OpenTelemetry is built. And this is how it enables us to be vendor neutral, and it helps us to standardize the export and the collection of telemetry data. The number one component is the OpenTelemetry specification, which basically gives you all the rules, the data models, and it sort of has explained how the telemetry data would be collected and would be exported to different kinds of backends. So this is the OTel spec. The next thing is the language specific API and SDKs. And these are essentially what you use to instrument your application code, or this is what you use to instrument your applications on a Kubernetes infra, which we are going to cover in the later section as well. So instead of you using a vendor specific library, let us say I remember that previously folks, if you want to export matrix to Prometheus, you would have to use prom client, right, which is specific to Prometheus. But now what you can do is you can instrument using the OpenTelemetry SDK, export the metrics, and you can send that matrix to any of the observability backend which supports OpenTelemetry, right? So this is an advantage of using these language specific APIs and SDKs. The next component in the list is OTLP, and this is what provides you that vendor neutrality, right? This is basically the protocol in which the telemetry data is collected from your applications and gets exported to the relevant backend that you have selected, right? It's available in gRPC and HTTP, so you can configure in which protocol that you want to use this. But if you ask the question of how does OpenTelemetry provides that vendor neutrality, and how it solves the challenge of different tools having different data formats, this is how it does it. It uses OTLP, a single protocol for exporting and collecting telemetry data. The next important component in the list is the OpenTelemetry collector. We are going to cover the collector a bit more because that's the key aspect of OpenTelemetry. But just to tell you everyone about the collector a bit more, OpenTelemetry collector is basically the central service of OpenTelemetry. You can consider this as a CPU which takes in the data from all the different data sources and handles the processing and exporting of that data to the relevant backend. We'll look into this a little bit later in the next slide. Lastly is the Kubernetes operator. Again, this is a fairly important component which enables you to use OpenTelemetry in your existing Kubernetes infrastructure. Again, this is because this is so important, we are going to cover this in the next section. So let's dive into the OpenTelemetry collector, because this is important for you to understand. If you are new to the concepts of OpenTelemetry collector is the vendor agnostic proxy, or the service which actually receives, processes, and then exports the telemetry data, right? So it has got three components. The number one is the receiver, which you can see here. The receiver pulls or pushes the data, the data, or you can push the data from your application to the receiver. It will take the data, it will then send it to some processors. You can set up some some built-in processors. We're going to not talk about the processors in this. You can definitely check out the documentation to know more, because OpenTelemetry also helps you to process the data, to clean the data, so that you are only sending what's relevant to the observability backend. And at the end of the day, that will enhance your telemetry data, and it will enhance your visualizations at the end of the day, right? After the processors, it then sends it to the exporters, which will export the data to your selected backend. But just to give you an idea of how things work, yeah, Rajit, you were
Kunal,
saying something.
maybe I'd like to add a couple of things into that
Yes.
previous one.
Yeah.
So I think one of the things to highlight here is that the Open Telemetry collector or the Open Telemetry, like the pipeline, it's a very key component and a very powerful component, because this is where users can take ownership of their telemetry data, um, and uh, you know take actions on how to send, what to send, what information to prioritize, etc. Because with I mean, we all talk about the cost of observability these days. It's pretty massive, and one of the factors that increases the cost of observability is all the data being sent, and sometimes the customers or the end users don't have control over that pipeline of how the data is ingested and exported. And OpenTelemetry can give you the ability to actually, before you push it to an observability vendor, to take that data, curate it, and in some cases keep the data for your own usage as well, and then send it to the observability vendors OTel collector, right? Because you can also chain these collectors as well. So this in my opinion hands the power back to the customers, to the end users. And there's a lot of things you can do with these processes, right? I mean, this is not the webinar to kind of go deep into it, but things like sampling, whether it is some random sampling, or you can do tail sampling, head sampling, these kind of different sampling strategies, enriching data, where you can grab data from multiple sources to enrich the data that you collect, because that can help you improve the quality of the telemetry data and get better, deeper insights. So you can do a lot more of this closer to the source where you collect, than taking all of that data and trying to process it later on, which can increase the cost and the complexity, right? So this hotel, like if there's one area to focus on, it's here. There's a lot of power in this, and we'll talk more about hacking your open telemetry pipelines in one of the future webinars. Understand these concepts, and you can do a lot more to improve the quality of the insights you get, and take control. More important to me is taking control of your own telemetry data. We'll move on.
Interesting. Thank you so much for sharing that, Rajat. One takeaway from that is, the OpenTelemetry pipelines, how you configure that really is essential a component. And I think the other component is, if you search about this on the internet, it's called as collector patterns, which defines how you are deploying your collector in your infrastructure. right? So these are the two aspects that you need to take care of if you are thinking of using OpenTelemetry collector and use it to its full extent. I think this is a topic in itself for another separate webinar, so we are going to go dive deeper into both of these aspects in a future webinar as well, but I just wanted to mention it here while we are talking about this. Just to give all of you an idea, this is basically the OTel collector configuration that you write. I am not sure if you're able to see this, but I hope people are able to see this now. All right. So this is basically the collector configuration that you define in order to configure your OpenTelemetry collector. So the first part is the receivers, as I mentioned, and in the receivers we have, you can define the protocols. So we have the HTTP protocol and the gRPC protocol, and you can see that the default port for the HTTP is 4318 and for the gRPC is 4317. So you can configure that. Then here we define the processors, right? And as Rajat mentioned, there are a lot of different kinds of built-in processors that OpenTelemetry supports. You have the batch processor where you can batch the telemetry data and send that in batches, right? You can decide the time for those batches. You can do there are various techniques for do sampling as well, right? But we'll discuss that. We'll discuss that particular number of processes and how you can use this processor in a separate webinar. But just to give you a good picture, this is how we enable that. This is how we define the processors. And then here you can see we are defining the exporters, right? So the number one exporter here we are sending, for example, to Jaeger. So we are sending traces to Jaeger, right? And then we are sending the metrics to Prometheus, and we have defined the addresses to both of these, right? So let us say in the future, right now you're using Jaeger and Prometheus, right? Let us say in the future you wish to change your observability backend. You don't have to change anything in your code. You just add your exporter here, and OpenTelemetry will take care of everything for you, right? So that's the kind of advantage that you get when you're using the OpenTelemetry collector, right? And this is the third important part of the collector config, which is the actual pipeline. So as I mentioned, all of these different components, the receivers, the processors, and the exporters work in a continuous manner as a pipeline. Here you're defining the pipeline, right? So the first collect the traces. Here we're defining what receivers to use, what processes to use, and what exporters to use. Similarly for metrics, and similarly we can do for logs as well, right? So this is I believe this is a good way for you to understand how you define OpenTelemetry and what are the configurations that you need to define this. I'll just quickly see if we have any questions in the chat before we move on to the next section.
Yeah, there's a question from John.
Yep.
What would be the benefit if I go through the effort of adopting OpenTelemetry, because I already have, all my metrics are scraped by Prometheus, and then it's already available in Grafana. Why would I need to adopt OpenTelemetry, right? Great question. I think first thing is that the OTel libraries that the SDKs can help you emit your metrics and traces, and in this case, Prometheus only will do metrics, right? So let's take the case of metrics. It can emit the traces using a standard sort of library, and instead of just being Prometheus. So for example, let's say tomorrow you want to use some other metrics backend, like say Victoria Metrics or OpenSearch or ClickHouse, right? You don't have to change everything because you're collecting them in a standard way, and you're emitting them in a standard way. You just need to change the backend, right? Or you probably need to take these metrics and correlate with something else. And there are there's also this case of exemplars where you are adding certain information where you can correlate your metrics to certain things. So there are advantages of adopting OTel. You can still get the same benefits of what you were doing before, but it opens up more possibilities for you. So great question, John.
Thank you so much for asking this, Joe. And I agree with the point of correlating, Rajat, right? You wouldn't only want your metrics, you would want to correlate with logs and traces as well to sort of try to understand where did the problem occur, right? Because if you look at metrics separately, logs separately, and traces separately, you'll not be able to figure out what was the root cause of a particular problem if it occurs, right? So if you have a unified view, if you are able to correlate these different kinds of telemetry data, then you'll have a better picture of where might the problem may have occurred.
Yeah. And
Right.
also the choice of backend, right? Like,
Yeah.
yeah.
Amazing. Thank you so much, Joe, for answering your question. Really appreciate it. So, if we bring everything together, right, I think this diagram sums up everything really well. So, you have all of your data sources on one hand, which is basically all your different services, which are built using different programming languages because you want to use the advantages of different languages for different operations that you are doing, right? You will instrument your telemetry data using the APIs and SDKs. You'll send the data to the OTel collector via the OTLP protocol. It will receive the it will receive the data. It will process the data. It will batch processing, sampling, metadata, so on and so forth. And at the end of the day, it will export the data to the relevant backend, which you configure in the OTel configuration file, right? So this is how things are working. And either you can use separate backends or you can use a custom backend, which helps you to visualize everything at one single place, right? So you have that kind of a flexibility if you have instrumented using the APIs and SDKs of OpenTelemetry. Amazing. So before we move on to the next section about using OpenTelemetry in Kubernetes, right? Because I know we have a few DevOps engineers in the chat who may be interested to know about that a bit more. I would want to touch about what are the different ways you can instrument using OpenTelemetry, right? The number one is using manual instrumentation, right? Instrumentation is basically enabling your application to export the relevant telemetry data, right? Which is the first step in the entire pipeline. So the first one is manual instrumentation. And here we are sort of defining the traces and the spans manually. We are defining the data points manually in our code. We are defining uh, what we want to see in terms of traces and spans in the observability backend of our choice, right? The advantages of this is it gives you full control, right? It gives you the full control of what kind of telemetry data do you want to expose from your applications. It gives you deep visibility because you can define custom traces, custom spans, custom metrics as well. I'm going to show a little bit more about this in the demo application that we'll be having at the end of this particular webinar, so you'll have a more clear picture. But the pros are you get full control. The con is, in this case, it takes a lot of time, right? You'll have to go through the entire application code. You'll have to figure out what are the data points that I want to set up, what kind of metrics I care about, right? So it gives you the control, but there are the cons as well, that it takes a lot of time. Next approach, which a lot of people use, and it's a great way to start, is auto instrumentation, right? And it requires very minimal to no code changes, right? uh, Here you can see I've got an example for you all to see. So what happens in auto instrumentation is that you use the predefined SDKs and the instrumentation libraries that OpenTelemetry provide based on the language that you're using, right? For example, in this particular case, we are auto instrumenting the very famous framework, the very famous components of Node.js application, which is Express, HTTP, MongoDB, and Mongoose. And these are basically the common instrumentation libraries that we're using from OpenTelemetry. And in the backend, they will set what are the different data points that will be configured in the backend, right? So we don't have to define all of the different trace points, all of the custom metrics. We can, but we don't have to. Just to get started, it will do everything for us, right? So minimal to no code changes needed. It's great for quick start. It's ideal for common frameworks and common libraries for a particular language. But one thing to understand here is that auto instrumentation is different from the perspective of who you are, right? If you are a developer, this is really important to understand for everyone who's watching the webinar right now. If you are a developer, you'll do auto instrumentation using the libraries, using the common libraries, right? You'll change to the code, you'll add these libraries, and that's the way for you to do auto instrumentation of your application. But let us say if you're a DevOps engineer, if you don't want to touch the code at all, what are the options for you to do auto instrumentation? So in that particular case, you'll use the OpenTelemetry operator, right? And on your Kubernetes infrastructure, you'll set up the instrumentation custom resources, and you'll have to configure the language specific annotations for your application. So in that case, you're not touching the application code itself as a sysadministrator, as a DevOps engineer, but you are still instrumenting the telemetry data, and you're still exporting that to the relevant observability backend, right? So in my opinion, this particular difference is really important for understand if you're a developer and if you're an operations, if you're a DevOps or an SRE engineer. In the demo that I'm going to show today, I'm following the approach of a developer. That means I've instrumented my code using the auto instrument common libraries, which we are going to show in a future webinar. Because this whole concept of OpenTelemetry operator is important, we'll definitely touch more about that as well. Awesome. I hope you don't have any questions till now. I just quickly look at the chat. Rajat, do you want to chime in? Any thoughts on things that we have covered till now? Any points I may have missed?
No, not really. I think a good explanation, and like you said, in a future webinar, we'll touch on the the auto instrumentation, not from a framework library perspective, but from the OTel operator perspective, right? Like how you can leverage eBPF or the Java agent to kind of get stuff going. But libraries is a great place to start. I think Node.js, like you said, has really good support. If you're using Spring Boot has amazing out of the box support, to the point that it just by changing a few things in your POM file, by adding the OpenTelemetry starter, it provides a lot of auto instrumentation as well, and also the ability to add custom spans and stuff like that. So there's a lot of options available for the popular languages out there.
Yep, totally agree. And if you're a developer who's watching this, you can check out the OpenTelemetry documentation. I'll maybe link it in the chat right now and see the supported languages, and you can explore what are the different instrumentation libraries based on the language which you are using, right? So you can explore it through the documentation as well.
I believe we've planned one for Spring Boot, right? Like where we will show both the both worlds, just for Spring Boot applications, doing a bit of a deep dive. So if you're using Spring Boot applications, keep an eye out for a notice about that particular webinar.
Yeah, make sure to follow us on the socials while you're at there. Cool. Okay, so just to quickly touch upon the OpenTelemetry operator as well, right? Because we want to touch that aspect as well, just to give you a good overview of how that would work if you're a DevOps and an SRE person. So how does that work is you'll install the OpenTelemetry Kubernetes operator. You can use Helm to install that, or you can check out the repository to know more about how you can install this. But the most popular option is Helm, right? So you install the operator, you set up the custom resource definition for the OTel collector. So you configure the receivers, the exporters, the processors, and the entire pipeline of your collector. And then when it comes to auto instrumentation, right, you'll use the instrumentation custom resource definition to instrument your particular app. And for your existing deployments, you'll add the annotations. So just to give you all a clear picture of how would that look like. So here you can see this is an example of the OpenTelemetry collector custom resource that we have created. And here you can see we are defining the entire OpenTelemetry config, right? So right from the receivers, the processors, and the pipelines. Basically the same thing, but this is basically a custom resource that you're defining, which is via the OpenTelemetry operator. Then what we do is we define the instrumentation custom resource, which is specific to the language that you're using. Again, I would recommend to check out the documentation, because every instrumentation language, every language specific instrumentation has different configuration options that you can explore using the documentation. This is specific to Node.js, so you can see that we are defining the common instrumentation libraries that you want to use. So in the first case, we were defining the libraries, right? Now we are just giving the names and the values here. So we want to we want to configure HTTP, Express, MongoDB, Mongoose. These are the common ones. You can explore a bit more. Similarly, this would be for Python. Similarly, this would be for any other languages that you're using, right? And lastly, for your existing deployment, you'll have to add this particular annotation here of inject Node.js. This is specific to Node.js, but again, there are a lot of configuration options, and there are a lot of options that you'll get on how you can add these annotations and what are the different options which are available. I would recommend you to check out the documentation. But we are going to cover this in a future webinar as well, where we are going to go hands-on into how you can configure this end to end. But for people on the chat, I hope you got an overview of how you'll use the OpenTelemetry collector. And this is like the most popular way of using OpenTelemetry in your Kubernetes infrastructure.
Yeah.
Right.
One thing to add quickly here, and it's a mistake that even I did right at the beginning when I was trying these things out. You have to choose one approach over the other. If you end up trying to do both, you will start to get subtle bugs because you have the auto instrumentation also working on top of the libraries that you have, and that can cause some subtle bugs. So be careful. Just use one approach over the other, and that's something I learned the hard way. All right.
Amazing. Yeah. Thank you so much for sharing, Rajat. I think that's important for everyone to understand as well. Cool. Who's ready for a demo? What could go wrong? Great. So what we are going to do is I'll just quickly share my other screen and I'll show you. So for the demo, we have a simple Mon application, right? And you'll be able to, it will bring everything together that we have discussed today. So you'll all have a good picture of what we have talked about. I'll quickly open and share my screen. Yeah, there are a lot of things open in my desktop right now. Sorry. Okay. Awesome. So let me bring in the diagram as well for you all to understand. So you will have a much greater picture. Yes. Okay. So what we are doing is we have a simple Mon application, which is MongoDB, Express, React, and Node.js. We have a simple front end, which is using React, which is running on the browser. And then in the backend, this is what is going on, right? The front end would make whenever you click something on the front end, I'll show you the application right now. Whenever you click something on the front end, it will make an API call to the backend service, to the backend ingress, and the backend will make the call to the MongoDB database, which is running on MongoDB Atlas, which is the cloud version of MongoDB, right? And it will save the data there. While you're doing this, because the Node.js code is instrumented, I'm going to show you how I have done that. It will the backend will export the matrix and the traces to the OpenTelemetry collector, right? And there are two approaches now. One approach is you can send your traces and metrics to separate backends. In this particular case, you can see that the traces are being sent to Jaeger, right? So you can configure that, or you can configure Prometheus to send metrics to Prometheus and visualize them using Grafana, right? So this is basically the open source way of doing things. But today, what we are going to do is the setup is the same, but at the end, the OpenTelemetry collector is sending the metrics and the traces to Randoli agent, and we'll be able to view the metrics and the traces on a unified view on the Randoli dashboard itself, right? We're going to focus on traces today, just to show you all how does that look, because I would want to explain the concept of context propagation as well while we're doing that. But yeah, this is the setup that is what we are going to show you today. Cool. I'll just quickly show you what is happening in the code itself. So this is how you'll define your backend tracing file, right? I'll just quickly, without confusing anyone, I can quickly walk you through it. First, we're defining the Node SDK, as I mentioned. So because this is the backend for Node. Similarly, you'll do this for Python. You'll use the Python SDK, and similarly, you'll do this for Golang as well. And then we are getting the Node instrumentation from there, right? Node auto instrumentation. The two important components to look here are the OTLP trace exporter and the OTLP metrics exporter, right? And this is how we are exporting the metrics and the traces via OTLP to our OpenTelemetry collector, which is deployed on our cluster, right? If you're using, let us say, a local OpenTelemetry collector using Docker, you'll configure that particular endpoint to send traces and to send the metrics to that particular collector. Cool. The last thing we are configuring here, which is again important to understand, is the trace context, which we talked about, right? So I'm going to show you how things are working here. So here we are configuring the the OTLP endpoint, which is basically connected to our OTel collector deployed on the cluster. And then we are configuring the trace exporter, which will send the traces. Here we are configuring the metrics exporter, which will send metrics every 15 minutes to the OpenTelemetry collector, right? So it will. There are now, because we are talking about metrics, there are two configurations that can come into play. Either your application can push the metrics to the OTel collector, or your OTel collector can pull the metrics as well, right? So these are the two ways that you can use. In production, you would want your application to push the metrics to the collector because that's more optimal. But in a development setup, you can configure Prometheus, or you can configure the OTel collector to pull the metrics as well, right? In the interval that you can configure. Here we are defining the trace context propagator. I'll not go into the details of this, but as Rajit explained, we basically with each of the trace spans, we send the trace ID so that you can see end to end the entire request flow. When we'll show the dashboard, you'll have a much clearer picture of how this looks in real world. But this is how the instrumentation is looking like, right? So we are using the most common libraries, which is the Express, HTTP, MongoDB. So at the backend, these are all. This will enable us to trace the different data points based on these libraries that we have selected, right? The Express, HTTP, and MongoDB, right? Then we are starting the SDK, and this is basically the configuration for the backend. Similarly, what we are doing is for the front end, right? So front end is based on React. So if you want to use OpenTelemetry SDK to trace the front end request, you use the web tracer provider, which is from the SDK Trace Web, which will help you to trace, which will help you to capture the traces from the UI itself, from the front end. And then we are using the some more libraries, for example, documentation load instrumenter, which will track the load on your front end, right? Fetch instrumentation, which will track the API call that your front end makes with the backend, right? So this is something that you may want to configure as well. And the rest of the configuration remains the same, right? For the auto instrumentation on the front end side, we are using this get web auto instrumentation right here. And if I go and if I show you what is happening here is, so it's capturing the HTTP request, it's capturing the load as well, and it's capturing the user interaction. User interaction means when you click on the front end itself. So this is enough for the code. I'll show you how things are working in the UI itself. Maybe if I show you right now. Okay. So this is what the front end looks like. So if you click here, and it increases the counter. In the backend, it's updating the MongoDB database, right? So you have the data which is being stored in the database. I'll just let it load for 2 minutes. Whoops, just a second. Yeah, I think this is what happens when you try to do a live demo. I don't think that the demo gods are with me here today, but yeah, I hope you get the idea, right? The data is being saved on MongoDB. Okay, we let this load. So you can see the data is getting saved in MongoDB. So you have the database, right? But let's see how does the traces looks like. Okay, so this is the Randoli UI, which is we are using as a custom backend. This is OpenTelemetry native, so you can instrument your code using OpenTelemetry, and you don't have to worry about touching that again. If we head over to the observability snapshot, which will basically which will generate you the observability data on demand at that particular time for your entire application. for that particular deployment. Basically, if we hit fetch observability data, and you can see, we can firstly we can see the metrics of that particular deployment. We can see the memory being used, the CPU millicores being used. These are the span metrics. Now I'm not going to go into the depth of what are span metrics, but the important point to note here is that this is the section we care about right now, which is the distributed tracing part, right? So here you can see that we have got these huge number of traces because we've been testing this out for a few days now. But here you can see the individual traces basically which are getting tracked. And if I open one of them, you'll be able to see the entire trace view from the front end till the database call, right? So you can see that when we clicked on the front end, when we incremented the counter, this particular function was called in our front end, which is the increment counter, which made a post request via Nginx to our backend, which is the counter item. And then we had some middlewares in our code, which we had configured. Then the request went to the MongoDB, it updated MongoDB, and that's how things worked in the backend. So because we configured context propagation on the front end and on the backend side, that's how you are able to view the entire request flow end to end, right? Because with each span, with each trace, that particular context is getting is transferring through each request, right? I hope this gives you a clearer picture of how things are working. Rajat, anything I missed? Do you want to chime in here and show people like anything I missed or anything you want to add here?
Yeah, so I mean, maybe you could click on some of this. So at like overall, you could see from the front end to the back end. So for example, let's say this could be like an order system or anything. Like your users complain saying, "Hey, I'm seeing some issues. It's either I'm getting errors or it's taking too long to load." Right now, we want to know. Uh, where is the slowdown happening, right? And this gives you from you see the front end, then you see the so in the front end we're talking about what's running on your browser. It hits your Nginx. From Nginx it goes to in this case only a simple backend service, but it could be multiple um, microservices in that chain. So at a glance, you can see the entire call chain. If you yes, you see the like. So for example, let's say to increase the counter, it takes argument's sake. My eyesight is pretty bad, so I don't even know what the milliseconds is. Let's argument's sake. Let's say 10 milliseconds, right? It takes 10 milliseconds to update the counters. Now, what you want to find out is how long did it take for the backend to process it, right? And I mean, you can also see the latency between your browser into Nginx into the backend service, and then inside the backend service, there are a couple of things that happen, and you can see the different spans. In a more complex scenario, maybe you're doing some other queries, talking to other microservices, so you can get a breakdown of those individual steps to identify where the time is coming from. So in this particular case, you can even see the call around the database, right? Like updating it. And I believe I can't really see without my glasses, but I can. It looks like it's reading, and there's a query and stuff like that too. So it breaks down all those individual steps. It gives you a really good understanding of where the problem might be, so you know where to look for when it comes to optimizing. Assume you had an error in this call chain, right? Then the trace will hopefully capture some of that information. So now you can understand where the error is coming from very quickly, and then get some details around it. Like for one of the things that I don't think we have enabled it, but one of the things that can what you can easily do is click on the logs. I don't think we've enabled it here, so that you can quickly go to the logs for these traces, right? So you can do this with other means as well. The real star here is like OpenTelemetry, because there are ways to annotate it. Like for example, you can instrument your logs with the same trace ID. In Node.js, you can do it in like in log4j, you can add it as a field. So now what you can do is you can correlate your trace with a particular log entry. So let's say you found an error here. Now you can look at the logs to get further information, right? And or you if you have certain metrics correlated using exemplars, you can then go and look at those to see, like, get a breakdown of, like, what may have caused this slowness, right? Okay, maybe click on one of these spans around the database, if you don't mind.
Sure.
Yeah, show me the tags, if you don't mind. Okay, now it's hard for me to see what it is, but if you can see, it tells you the span type is database, right? It's a database call. It tells you the collection name, if I'm not mistaken. So it's a find one operation, right? It says the collection name. Going down a little bit more, in some cases, you may actually, for example, if you do SQL, you can sometimes even see the SQL query. So if you're an operations person, like an SRE, DevOps, you're trying to debug, you have a lot of information that you can look at and communicate to the developers. Or let's say you're debugging a production issue together. Now the ops person and the engineering team, you like in the developers, you're like, all looking at the same kind of data, right? And you can see exactly which database operations were done, how long it took, what was the what was there any errors, etc. It gives you that, like, level of visibility that is otherwise going to take a lot more time if you try to collect all this information manually, right? So this gives that great amount of visibility from your browser all the way to the database and back, right? So the entire round trip you can instrument it with a few few annotations and some like basic information. You can get it going. And in a future webinar, we'll show the auto instrumentation just from the from the OTel collector itself. You could get similar similar visibility by using those auto instrumentation as well. So this, I guess, hopefully shows the sort of like the benefits of OpenTelemetry, where you can get this kind of visibility in a like annotate your instrument your applications in a vendor neutral way. So assuming tomorrow you switch to a different observability vendor, you shouldn't have to change your applications. You shouldn't have to change how you instrument it. This kind of information should be visible, should be able to be presented in the other observability vendors solution. Or you switch to some sort of open source solution like using Jaeger or Prometheus, you should be able to see it. So this gives the customers, the end users, more power, give them more options without being vendor locked into a particular vendor system. Yeah.
Yep, totally agree with that. And coming back, just quickly touching back to the point of, if you want to change your observability vendor, let us say, right, it's really easy for you because you instrument your code once and then you don't touch that for a while, right? Because you only have to change uh, your OTel configuration and point that particular exporter where you want to export your telemetry data. So you instrument once and you can do this configuration again and again, so you don't have to change this again and again. And I think the same point that you mentioned, Rajit, about that's how OpenTelemetry is able to enable vendor neutrality, right? And because all of the data, I can maybe increase the size of this, because all of your telemetry data is following the same protocol, which is OTLP. That's how we are solving the problem of different formats, right? Of that being followed by different tools.
Right. And if anybody is wondering, like, where is the vendor adding value in this chain, is most vendors help by providing OTel pipelines or OTel like a standard OTel collector to kind of get going. Some customers prefer to have their own OTel pipelines before, so you can chain them together as well, so if you want to take ownership of that. And then where they really add value is in taking this data and processing it at scale and providing deeper insights into it, right? So that's where the vendors now have to, in my opinion, we all work together, I guess, on the collection phase and making it neutral, and then they'll have to sort of work hard on the visualization and insights and other aspects to provide value to the customer. So it's a great. I think that's how it should be. And then this is how it can sort of improve observability for everyone and
Absolutely.
affordable for everyone. Yes.
Yeah, I could totally agree with that. Right. Thank you so much for sharing that information, Rajat. I think we are at the end of this webinar. I'm seeing we have crossed the 1 hour mark as well. But I think we would love to know from your side
I'm not sure what happened. I think looks like Kunal's connection died, or could be mine. I'm not sure what happened as well. We'll give it a minute. I think he'll probably try to end the stream soon. For folks still on here, can you guys hear us? Maybe put something on the chat to say. Or it could be me that lost the connection. I'm not sure. Okay, so it looks like, I think, maybe something happened with Kunal's connection. That's okay. I want to thank all of you for joining today's session. Appreciate all the support, all the questions. We'll be posting a recording soon and some additional reading material with the recording and the follow-up LinkedIn post. Thank you very much. See you all. Take care. Bye. Thank you.